Welcome to Course 3, Module 2, Chapter 4, where we explore how digital platforms are transforming participative collaboration in the circular economy. In this chapter, we will examine the ways digital tools empower stakeholders to engage in design, innovation, and problem-solving, regardless of their location. Digital platforms have become essential for overcoming traditional barriers to collaboration, fostering inclusivity, transparency, and co-creation in complex systems. By enabling virtual teamwork, these technologies ensure that diverse voices are heard and integrated into sustainable solutions. We will also discuss real-world case studies to illustrate these concepts in practice. In this chapter, we will cover the following key topics: the role of digital platforms in participative collaboration, the new paradigm of digital tools for collaboration, practical approaches to participatory design and stakeholder engagement, and 3 case studies: Renault's closed-loop automotive manufacturing, Hindustan Unilever's EPR initiative in India, and Tontoton's ocean-bound plastic recovery model. Each section will highlight how digital technologies and collaborative strategies drive circular economy transitions, with a focus on inclusivity, innovation, and real-world impact. By the end, you will understand how these approaches can be applied to your own projects and answer the multiple-choice questions from the teacher's guide. Introduction to digital platforms and participative collaboration. Digital platforms have fundamentally changed how we approach design, collaboration, and innovation in the circular economy. These tools empower participatory design by allowing stakeholders from around the world to actively engage in projects, regardless of their location. Virtual collaboration tools remove geographic barriers, making teamwork more inclusive and seamless. By fostering transparency and shared innovation, digital platforms ensure that diverse perspectives are integrated into complex system designs. This transformation is crucial for advancing circular economy initiatives, where co-creation and stakeholder engagement are key to developing sustainable solutions. Understanding these dynamics will help you answer questions about the benefits and challenges of digital collaboration. The shift to digital collaboration has made design and innovation more accessible and inclusive on a global scale. Digital platforms empower stakeholders to actively contribute to projects, enhancing participation and idea sharing. By removing geographic and social barriers, virtual collaboration ensures that diverse groups can engage in county creation, transparency, and trust building. This transformation is critical for the circular economy, where stakeholder engagement drives sustainable outcomes and systemic change. Digital tools support continuous feedback and adaptation, making collaboration more dynamic and effective. These concepts are important for understanding how digital platforms empower diverse stakeholders and foster participatory design. This slide references information from the following file: https://f/joanneum.share.com/site/EB-transfer-center-on projects/_b268-7b74E47E1%7D and file equals chapter%204.docs and action equals default and mobile direct equals true. Digital platforms have revolutionized the way we design, collaborate, and innovate. This chapter explores how digital tools empower participatory design, enabling diverse stakeholders to contribute meaningfully to projects regardless of their geographic location. By facilitating virtual collaboration, digital platforms help overcome traditional barriers to engagement, ensuring inclusivity, transparency, and co-creation in complex systems design. Image source: Microsoft 365 Content Library. Digital tools and the new paradigm of collaboration. Innovative digital tools are reshaping collaboration in the circular economy. Cloud-based platforms allow real-time and asynchronous collaboration, breaking geographical and time barriers. Tools like Slack and Microsoft Teams provide instant messaging and video calls, enhancing team interaction and decision-making. Collaborative design software such as Figma and Miro supports co-creation through prototyping, brainstorming, and iterative design cycles. These technologies enable both synchronous and asynchronous participation, supporting iterative design cycles and overcoming geographical and temporal barriers. By facilitating co-creation and efficient teamwork, digital technologies are redefining how organizations approach circular economy projects, making collaboration more inclusive and impactful. Small and medium enterprises, SMEs, often face resource constraints that limit their ability to adopt circular economy practices. Digital technologies play a crucial role in bridging this divide, enabling SMEs to allocate resources more effectively and participate in circular transitions. A systematic review identified 13 critical digital functions that enhance synergies and improve circularity. By leveraging digital tools, SMEs can overcome barriers, access new opportunities, and contribute to sustainable business models. This digital enablement is essential for scaling circular economy strategies across diverse sectors. Understanding these benefits is key to answering questions about how digital technologies help SMEs overcome resource constraints. Digital technologies have significant sectoral impacts, particularly in industries like plastics and manufacturing. In the UK plastics sector, digital tools support collaborative business models focused on value retention and data as a service. German manufacturing firms with a strong digital focus show higher adoption of circular business models and innovation. Digital platforms also enable co-creation approaches that integrate circularity into product design at both the product and ecosystem levels. As meta-organizations, digital platforms orchestrate resource reduction, reuse, and recycling across large ecosystems, driving systemic change in the circular economy. These examples illustrate how digitalization drives circular adoption and innovation. Participatory design in practice. Stakeholder engagement through technology. Participatory design emphasizes the active involvement of stakeholders through technology, ensuring their perspectives shape effective circular economy solutions. Stakeholder engagement is crucial for value creation and the overall efficiency of circular systems. Developing strategies to overcome participation barriers and boost involvement is essential for success. By leveraging digital tools, organizations can facilitate structured engagement, integrate diverse insights, and foster collaboration among all participants, from end users to policymakers. This approach strengthens circular economy ecosystems and supports sustainable innovation. These principles are important for answering questions about the role of participatory design and stakeholder engagement. Digital tools provide structured workflows for stakeholder mapping, enabling organizations to identify and organize participants effectively. Collaborative canvases support virtual co-design workshops, allowing remote teams to develop solutions in real time. Live feedback dashboards capture participant insights, facilitating ongoing refinement of designs and strategies. These technologies ensure that stakeholder needs and perspectives are integrated throughout the project lifecycle, enhancing engagement, transparency, and trust. By supporting key activities like mapping, county design, and feedback, digital tools drive successful participatory design in the circular economy. These concepts are essential for answering questions about digital tools in stakeholder engagement. Trust between stakeholders is essential for successful collaboration and achieving circular economy goals, especially in projects like housing retrofits. Active participation and shared ownership, facilitated by technology and social interaction, help cultivate trust and engagement. Inclusivity is critical, particularly when involving vulnerable groups, to ensure all voices are heard and considered. Comprehensive engagement frameworks should span the entire project lifecycle, addressing power dynamics and inclusivity challenges. By fostering trust and inclusivity, organizations can build resilient and effective circular economy initiatives. These principles are vital for answering questions about building trust and inclusivity in participatory design. Case study: Renault's closed-loop automotive manufacturing in Europe. Renault is pioneering a closed-loop manufacturing system that recycles and reuses automotive components to minimize waste and environmental impact. This approach integrates circular economy principles such as recycling, refurbishing, and reuse, supported by advanced digital technologies and strong stakeholder collaboration. Renault's model demonstrates how these elements work together to create sustainable manufacturing cycles, offering a blueprint for industrial transformation. By combining digital innovation with collaborative practices, Renault sets a compelling example for circular economy adoption in the automotive sector. These insights are important for answering questions about closed-loop manufacturing and circular economy principles. At the heart of Renault's circular strategy is the Flins factory, Europe's first circular economy factory dedicated to mobility and net zero emissions by 2030. The factory operates through 4 interconnected centers: retrofit, refurbishing and converting vehicles; re-energy, developing energy storage solutions; recycle, remanufacturing parts and recycling materials; and restart, innovation and knowledge transfer. This comprehensive framework supports sustainable vehicle life cycles and industrial innovation, demonstrating Renault's commitment to transforming its operations and skill sets for a circular future. These details are essential for answering questions about Renault's circular economy framework. Renault's circular strategy includes meticulous material management, repurposing aluminium offcuts and end-of-life vehicle materials into new components. Textile recycling innovations use recycled fibers in vehicle models, while recovered polypropylene from bumpers is converted into new plastic parts. Remanufactured components are cost-effective and eco-friendly, saving energy, water, and chemicals compared to new parts. These practices highlight Renault's commitment to resource efficiency and sustainability, setting new standards for material recovery and circular manufacturing in the automotive industry. These innovations are important for answering questions about material management and recycling. Digital technologies and stakeholder collaboration in Renault's model. Renault's closed-loop system is enhanced by digital technologies that monitor and optimize the life cycle of automotive components. Product Lifecycle Management (PLM) systems manage comprehensive product knowledge, while IoT-enabled tracking devices collect real-time data for continuous monitoring and decision-making. Digital twin technology simulates real-world conditions, predicting maintenance needs and optimizing resource use to extend component lifespan. These digital tools provide the infrastructure for efficient, transparent, and sustainable circular manufacturing. Understanding these technologies is key for answering questions about digital tools in lifecycle management. Blockchain technology provides decentralized, secure, and immutable records, ideal for tracking recycled materials in supply chains. Renault uses blockchain to ensure traceability and compliance of recycled components, fostering trust and transparency among consumers, regulators, and partners. An industry-wide blockchain platform certifies component compliance, supporting circular economy initiatives by verifying material provenance and building confidence in sustainable practices. Blockchain is a key enabler of transparency and trust in circular supply chains. These concepts are important for answering questions about blockchain in circular economy models. Renault's success in closed-loop manufacturing relies on extensive stakeholder collaboration, engaging engineers, suppliers, dismantlers, policymakers, academics, and customers. Digital platforms and innovation hubs facilitate co-development of solutions, guidelines, and training in circular mobility. These collaborations influence eco-design, enhance recycling, shape legislation, and promote research and education. By fostering systemic transformation through multi-stakeholder engagement, Renault demonstrates the power of collaborative approaches in advancing the circular economy. These insights are essential for answering questions about stakeholder collaboration and systemic change. Case study: Hindustan Unilever's EPR initiative in India. Hindustan Unilever Limited, HUL, addresses India's plastic waste crisis through a comprehensive extended producer responsibility (EPR) initiative. The strategy aligns with national sustainability goals and regulations, such as the Plastic Waste Management Rules and Swachh Bharat Abhiyan. HUL's vision is to transition from a linear waste model to a regenerative circular economy, focusing on systemic changes in packaging design, use, and management. Collaborative implementation and technology integration are key to the effectiveness and sustainability of HUL's EPR program. These principles are important for answering questions about EPR strategies and national alignment. HUL's EPR strategy is built on the less, better, no plastic framework. Less plastic reduces usage through packaging redesign. Better plastic improves sustainability with recycled content and recyclable solutions. And no plastic eliminates plastic by using alternative materials. These approaches drive circularity by minimizing waste, promoting recycling, and fostering innovation in product design. HUL's ambitious targets include halving virgin plastic use and making all packaging reusable, recyclable, or compostable by 2025, setting industry benchmarks for sustainability. These details are essential for answering questions about plastic reduction strategies. HUL's EPR implementation relies on robust waste collection and processing infrastructure, partnering with organizations to collect post-consumer plastic from over 160 locations. Material recovery facilities, MRFs, streamline segregation and processing, creating livelihood opportunities. Community engagement programs promote source segregation and educate on waste management, while initiatives like Project Uttaan empower waste workers through social protection and improved livelihoods. These efforts demonstrate HUL's commitment to comprehensive, inclusive, and sustainable waste management. These concepts are important for answering questions about waste collection and community engagement. Digital technologies and collaboration in HUL's EPR initiative. Digital technologies are essential for managing data, tracking waste, and ensuring compliance in large-scale EPR implementations. HUL partners with technology-driven companies to access advanced digital solutions for compliance and traceability. These collaborations enable efficient and accurate fulfillment of EPR obligations, supporting robust waste management and circularity. By leveraging digital platforms, HUL enhances operational efficiency and transparency, demonstrating the value of technology in sustainable business practices. These principles are vital for answering questions about digital tools in EPR initiatives. Multi-stakeholder engagement is central to HUL's EPR initiative, involving government bodies, NGOs, industry partners, recyclers, and producer responsibility organizations, PROs. These partnerships support integrated waste management, combining formal and informal recycling systems and enabling social inclusion programs for waste pickers and vulnerable communities. HUL's membership in the India Plastics Pact highlights its commitment to collective action and ambitious plastic packaging reduction goals, showcasing the importance of collaboration in driving circular economy progress. These concepts are essential for answering questions about stakeholder collaboration in EPR. Tontoten's model addresses ocean plastic pollution in Southeast Asia by empowering local communities to collect hard-to-recycle plastics before they reach the ocean. Waste pickers receive stable income, safety gear, training, and healthcare, supporting both environmental cleanup and social empowerment. By focusing on orphan plastics and community-led recovery, Tontoten creates sustainable solutions that benefit vulnerable workers and coastal environments, demonstrating the power of local action in the circular economy. These principles are important for answering questions about community-led recovery and empowerment. Case study: Tontoten's model for ocean-bound plastic recovery. Tontoten's model addresses ocean plastic pollution in Southeast Asia by empowering local communities to collect hard-to-recycle plastics before they reach the ocean. Waste pickers receive stable income, safety gear, training, and healthcare, supporting both environmental cleanup and social empowerment. By focusing on orphan plastics and community-led recovery, Tontoten creates sustainable solutions that benefit vulnerable workers and coastal environments, demonstrating the power of local action in the circular economy. These principles are important for answering questions about community-led recovery and empowerment. Collected plastics are sorted at material recovery facilities, with recyclable materials sent to recyclers and hard-to-recycle items used for energy conversion or transformed into durable boards for local use. Digital verification and independent certification ensure fair, safe, and environmentally sound practices. Transparent recording of collections builds trust and accountability, supporting scalable and credible circular solutions. Tontoten's closed-loop approach demonstrates how technology and verification can enhance sustainability and community impact. These concepts are essential for answering questions about material recovery and digital verification. Tontoten leverages digital traceability technology to verify plastic origins, building trust with partners and demonstrating impact. The plastic credit system enables companies to fund projects that remove ocean-bound plastic equivalent to their footprint, supporting corporate social responsibility and environmental leadership. Partnerships expand awareness and promote a circular economy for plastic-free coastlines, illustrating how business collaboration and digital tools can drive sustainable change. These principles are important for answering questions about business partnerships and plastic credits. Digital platforms are key drivers of collaboration and innovation in the circular economy, enabling seamless stakeholder engagement and participative problem-solving. Inclusive collaboration fosters sustainable practices and scalable impact, helping businesses and communities achieve lasting change. By embracing technology and participative approaches, organizations can advance circular economy initiatives and build resilient, future-ready systems. These insights are essential for answering questions about the role of digital collaboration in circular economy transitions. Thank you for your attention. Next, we continue with Module 3, Chapter 5.